So we're just going to go over the answers for lesson 10 on significant digits. I'm going to pick up on number 3 because in the video at the top of your form, I've already done numbers 1 and 2. So let's go ahead and pick up on number 3. So we have 6.7 meters times 7.00 meters. Okay, so I'm going to use the calculator. We'll do 6.7 times 7.00. Calculator tells me 46.9, and I know that'll be meters squared. Now, let's look at this. We're multiplying. So do we look at decimal place or significant digits? When you multiply, divide, you count significant digits. So 1, 2 significant digits. And then the zeros are on the right of the decimal. So they count. So it'll be a total of 3 significant digits. Which one's a bigger number, 2 or 3? It'll be 3. So we count the lowest. So we look at the 2. If we have 2 here, we're not allowed to have more than 2 right here. So this needs to go down to 2 significant digits. So we can keep the 4, we can keep the 6, but the 9's got to go. That'll round it to a 47 meters squared. Okay, number 4. We have 10.00 grams divided by 5.000 grams. So with this one, this is similar to an example I did, but we'll have 10.00 grams divided by 5.000 grams. So when we do that, obviously it's going to be 2, but how many decimals do we keep? So look right here. This has 4 significant digits. All of your zeros are on the right side of the 1, and you have a decimal present. This has 3 zeros on the right of the 5 and a decimal present. So both of them end up having 4 significant digits. So my answer is supposed to have 4 significant digits. So my answer will be 2 point, and we'll go 1, 2, 3. So we have a total of 4. Okay, number 5. Number 5, we're going to do 3 times 5.5 liters. And what that's going to do, when we do 3 times 5.5, if you just do the math, we should end up with 16.5. But how do we decide if we round it? Look at the decimal place of the measurement. This is not a measurement up here at the 3. So we just go, this is at the 1's place, so keep it at the 1's place, and we're good. I know that has 2 significant digits, that has 3, but when you multiply, divide a measurement and a non-measurement, you don't care about that. All you care about is the decimal placement. Okay, number 6, 3.0 milliliters times 4 milliliters. So for number 6, we're going to do 3.0 milliliters times 4 milliliters, and we'll get milliliters squared. 3.0 times 4, we'll get 12. And now this is where it gets weird. This only has 1 significant digit. I'm sorry, this has 2. This has 1. Let me fix that. So up top, 3.0 has 2 significant digits, but the 4 has only 1. So our answer is only allowed to have 1. So we can keep the 1 in front, but this has to go. So at 12, do you round up to 20 or down to 10? Down to 10. No decimal, that way the 0 is insignificant. Milliliters squared will be our answer. All right, moving on to number 7. 10 milliliters minus 3.5 milliliters. Let me actually get this. This is by far the weirdest question. A lot of people that don't understand this, that struggle with this, this is a question that makes them so frustrated because of how the answer turns out. So you go ahead, you do your math, you get 6.5 milliliters. However, do we know what's right there? At that 0, no. This could be 17 minus 3.5. This could be 19 minus 3.5. We don't know what's in the decimals either. It could be 19.3 minus 3.5. So for us to say with confidence it's 6.5 would be a lie. We don't know because we don't know what's right there. So our best guess is taking this So if I go like this, if we have, okay, if it's like that, we're not allowed to have anything in this decimal. Neither one of them had it there. We're not allowed to have anything in this decimal because the 10 has nothing there. We're not even allowed to have anything in the ones place because there's no decimal, so that's not a significant zero. So all we're allowed to have is in the tens place. So with the 6.5, we can't have the 5, we can't have the 6. All we get to have is what's right there. So with 6.5, round down to 0 or up to 10. It would be up to 10. So we would get 10 milliliters with no decimals. It seems weird, but remember, we're saying we don't know what was right there. So the best guess is actually that there's going to be a 1 followed by I don't know. Okay, because more than likely, it's a higher chance that this is 13.5 or bigger than that it's lower than 13.5. So because if it's 14, 15, 16, you'll have a 1 right there. We don't know right there. That's why these rules work. Okay, last but not least, we're going to do 1.001 minus 0.0095. Okay, so that should come out to, we just subtract that, we have 1.0. You know what? It's been a long day. I'm tired, and I don't want to mess this up. Let me just punch in the calculator. 1.001 minus 0.0095. Okay. So, yeah, I was about to totally mess it up. This should be, our answer should be, so when we do minus 0.0095, yeah, I would borrow all the way over if I did it the long way. So we get 0.9915 grams and grams. So this is grams. Okay, so when we do this, that's our answer. And it's kind of like, what in the world? So look at what we need to pay attention to now. We have this long answer. We need to round somewhere. Can we keep what's right here? Yeah, because significant right there, significant right there. There are zeros. There's a decimal present. So yeah, they're significant. Do we know what's right here in both places? Yes, we keep that. Right here, a 1 and a 9, always significant. But look right here, if I move this over, do we know what's right there? We don't. It's a question mark right there. So you cannot keep that. So you need to take that 5 and round up to get 0.992 grams. And that ends up being our final answer for this one. Okay, so hopefully this makes sense. As always, guys, email me if you have any questions, and I will talk to you next time.